problem, we're going to state the transformations of the basic reciprocal function 1 over x. This is one of our parent functions. We're going to start by identifying any asymptotes and then graph our function and use limits to describe the corresponding end behavior. So on our problem right here, we want a 1 in our numerator, and since I don't have anything going on in my numerator except the -2, I can just factor it out front. And I get a -2 factored out front, and then 1 over x plus 3. This is as close to parent function form as we can get. We should be able to figure out our transformations now. The negative out front reflects over the x-axis. The 2 is outside of our function. When it's outside, it's a vertical stretch by 2. And then the x plus 3 is inside of our function. Remember, set that equal to 0, and if you get a positive number, you're moving right. If you get a negative number, you're moving left. So on ours, if we do x plus 3 equals 0, we get x equals a -3, so we're going left 3. Next thing we want to do is to find our vertical asymptotes. Again, since this is our reciprocal function, you just set your denominator equal to 0 and solve. And we should get x equals -3. And you can go ahead and graph that on your graph. To do horizontal asymptotes, since this is in our parent function right here, we don't have anything going on at the end. So it would be at y equals 0. If that's uncomfortable, look at the degree of your numerator and the degree of your denominator. The degree on the top is smaller than the degree on bottom, so we get y equals 0. And you can go ahead and graph that one as well. All right, go ahead and go into your calculator. Let's graph this thing, take a look at it. Make sure you're putting your denominator in parentheses if you're using the divide sign. Okay, when you graph it, you should get something similar to this right here. Let's look at the end behavior, which is the left and right hand side of our graph. Does the graph go left forever? Yes, it does. So the limit as x approaches -infinity. The graph is getting closer and closer to 0 from above. Does the graph go right forever? Yes, it does. So the limit as x approaches +infinity, our function is getting closer to 0 from below. Now on this graph, we only had one vertical asymptote, so when we have to talk about asymptotic behavior, we can just do that one asymptote. Now remember, we have to go from the left and right sides of this asymptote. Sorry about that mess up there. So the limit as x approaches -3 from the left. So we're looking as we head from the left, our graph is going up. And then we have to head from the opposite direction. So the limit as x approaches -3 from the right. I'm getting closer to that asymptote. My graph is going down. It's approaching -infinity. Okay, on our second transformation problem, we still want to put it into the 1 over x format if we can. Identify the horizontal and vertical asymptotes, graph it, and then do the limits on the ends and any vertical asymptotes that we have. So our problem is a little bit harder than the last one because I have a variable going on in the numerator as well. So when the equation doesn't look like our basic reciprocal function, or I can't get it to be a 1 over, then we're going to use long division to identify our transformations easier. Now on this particular problem, you could use synthetic as well, but I want to show you long so that you can do it if you get to a harder problem. So we're going to do long division on this problem. So we take x minus 2 and divide it into 3x minus 7. Well, how many times does x go into 3x? The answer is 3. That goes up on top. Then you multiply your entire divisor by 3. Draw your line, and since we're subtracting, we're going to go in and change our signs right here. We get a -1. X can't go into a -1, so we put our plus sign and then our remainder over our divisor. Now this is technically in the form that we need, but it doesn't look like what we're used to. So all I'm going to do is rewrite this by switching the two positions around. Now by switching the two spots around, this looks more like the basic reciprocal function. Now we can talk about transformations a little bit easier. So we're leading off here with a negative out front. So you know if it's outside, we're going to reflect over the x-axis. Set your denominator equal to 0 to figure out if you're moving right or left. When we do that, we get x to be a positive 2. So we are going right 2. And then the number at the end pushes us up and down. Since it's a positive 3, we're going to go up 3. Now we can go ahead and sketch our graph. To get our vertical asymptote, again, just take your denominator, set it equal to 0, and solve. So we should get x equals 2. Go ahead and graph that one. Then our horizontal asymptote just comes from this number at the end, since I don't have a variable up in my numerator, so this is y equals 3. And if that's uncomfortable, go back up and look at the original problem. Your degree on the top is 1, your degree on the bottom is 1. When they're the same, you would just divide out your leading coefficients, so you would get y equals 3 there as well. So go ahead and draw in your horizontal asymptote. And then take a second and go ahead and enter this one into your calculator and get us a sketch. When you graph, you should get something that looks like this. All right, go ahead and fill in your end behaviors. That's the left and the right-hand side. And then when you're done with that, go ahead and do your asymptotic behaviors. Go ahead and pause the video here for just a second while you get this done, and then when you are ready to check your answers, play. The end behavior, the limit as x approaches -infinity, your function approaches 3 from above. And the other side, the limit as x approaches +infinity, your function approaches 3 from below. All right, to do the asymptotic behavior now. Okay, the limit as x approaches 2, as you're coming from the left, our function approaches +infinity, so you can see your graph is going up right there. And the limit as x approaches 2 from the right, your function is approaching -infinity, so you can see it's going down.